Hey, what's going on, Sebastian?
Hey, how are you?
Not bad. I'm having a bit of trouble getting my testnet node running this morning. You should, what day was this? Okay. All right. Well, I'm going to try something over here while we get up and running. All right, let's see if that works. Hey, Steve. Hey, Curtis. Hey, Nelson. What's up, everybody?
Hi, guys. Good morning.
I've been really excited about this session. This is one of my favorite things to do is test smart contracts on Cardano CLI just to see what it what pieces it really helps us put together and to really think about the relationship between contracts and transactions. But I've been using node 1.35.3 without issue to connect to testnet, and finally stopped working this morning. So I'm rolling back and hoping that this earlier version works, but we'll see. Anybody else running a testnet node today?
Hello.
Hey, Nelson.
Hey. Yeah, James. So I also tried to run the node and it wasn't working for me either. So I think there's a new commit in the GitHub with a new commit about 4345 sync%. I haven't tried it yet, but I just pulled it now and maybe that might be working.
Great. Yeah, I'm building. I saw that. Yeah, which commit is? And Dom, I read it too, and then I was fine. Yesterday actually, I ran without issue. I did everything I wanted to do. So that's the mystery to me, is why it didn't break sooner. But this will take just a moment for me to rebuild. Let's see if I can.
I'm so confused by what they're doing.
It's so weird. It's really hard.
I assume it's mostly because they broke testnet and now they have no way to do the pathway where mainnet will reflect exactly what testnet did, because they don't want to break mainnet and then fix it again. But yeah, it's so confusing.
What you just said makes as much sense as anything, right? And that's actually it's such a good spot. It's such a good spot to start. Hi, Trevin, Nicholas, Yuli, Lucas. Good to see everybody. Hey, so I'm not one to really like making excuses, but I promised everybody that the full project would be published Monday and Tuesday, and as you can see, it's not yet. And I couldn't be more excited about it in a certain way, because it's such a powerful example of what we're dealing with right now, which is multifaceted, right? On one level, we are between these eras of Cardano. We have testnet running on one era and mainnet running on another. That's a very unique situation. Most people who ever learn how to develop on Cardano, they won't be learning during a moment like this. So kudos to all of you for sticking with it. And even if that wasn't enough, we have the privilege of watching Mesh grow up in real time. And so they've introduced a couple of breaking changes because they're really trying to build a tool that will be scalable in the long term. And so I've been working close with Abdel Karim and Jingles to really how we get those contracts working. So that's why not everything is released yet, but it also presents the opportunity for us to really be in this together. Okay, it's not a joke when we say, you know, hey, you're a Cardano developer now, like you really are. I hope you're getting the chance to kind of see this process in motion and to kind of just start building up that confidence that when things don't work, it might not be your fault. It might be because the tools are still being built right in front of us. So yeah, just wanted to say thank you for that. And in case you just jumped in, I want to do some example transactions on testnet today to really think about what it means to use a compiled smart contract. But I got to rebuild my nodes. So that's going to take just a few minutes. So while that's happening, what other questions do folks have from any of the modules you're working on, or just questions that have come up along the way? Hey, Augustin, good to have you here. Hey, your sound is coming through like maybe really hot. Is your mic turned way up? It's like it's almost too loud to hear. We're getting
Too loud. Sorry.
Oh yeah, chat works too, but if you want to try again, that's good. Good. Okay, yeah. So the node is going to take a good amount of storage. The current recommendation is at least 100 gigs, and it might increase to 150 gigs is what they're recommending for future growth right now. This is, you know, the technical requirements just in terms of hardware of running a node locally and of running Plutus apps so that you can compile Plutus scripts on your own. Those are pretty high requirements. And so there's no doubt that that's a major blocker to Cardano development. And we just want to be really straightforward about that because these are precisely the sorts of challenges that might inspire us to build other solutions. So there's actually people on this call who have been experimenting with using, you know, remote Linux machines, like on a cloud service, for example, to run their node. I run Gimbal Stake Pool from a remote node. We use a Poland-based provider called Scaleway. And so that's always an option, is to run these things. Now, I know that might present a different learning challenge for people who have never done that before. And that too opens up development opportunities. And so anybody who's heard of Dandelion, which is the distributed infrastructure that Gimbal Labs is building, that's led by our co-founder, Roberto, you know, he's trying to address that problem directly of providing access to endpoints that expose services that, yes, are available to run locally, but are certainly very resource intensive. Yeah, Nicholas, it is a bit lower for testnet. That's right. Trevin, what do you think?
Yeah, so we've been using wallets like Game Changer, and I've been thinking every time we make a transaction using Game Changer, that has to be sent to like a node service provider, or because I assume that every time you want to make a transaction, something has to be synced with the blockchain, right? So a wallet is a light client, and I was thinking, if there is a server, then how does Game Changer pay for it? Like, is it free? Because if it's free, then it's not sustainable. So I was thinking, like, how does it work, or what's happening?
Thank you for that question. That's excellent. Okay, so Game Changer runs on Dandelion infrastructure, and neither of them have a sustainable business model yet, right? They've been building up these tools first and foremost as a community service, and you're exactly right. They're not financially sustainable yet. So that's an interesting and ongoing problem, obviously, that we're working on. But let's talk technical architecture for just a moment. Any light client, and a wallet is just one example of a light client. You can imagine dApps where there might actually be a wallet running on your behalf in the background. And that's actually something that the mesh team is also working on, this ability to spin up a wallet. For example, if you were going to build a game or some other dApp where you wanted to obscure the role of the wallet and maybe not even have people connect a browser-based wallet, but to just be connected natively within the dApp. This is going to be really helpful functionality for certain use cases. So what do you need, right, for a wallet or anything else that's running on kind of this light client architecture? Well, first, you need to be able to build valid transactions, and then you have to be able to submit them. So once the transaction is built, there is what's called the Submit API. Dandelion provides this. Blockfrost provides this. Koios, which you might have noticed and introduced just a little bit in some of the front end querying lessons or earlier in the course, Koios offers a Submit API as well. And so that's the part that says, okay, once I have built and signed a valid transaction, the last step is to submit it, and you need access to that service, right? If I'm running Cardano CLI locally, obviously, well, I have that service for myself and I can access it from Cardano CLI. But like you're saying, in any light client, I'm going to need to have submit access somewhere. And that's also an interesting topic to study a little bit more deeply, because if we look at issues of network neutrality, there were some big questions about the neutrality of the Submit API and who's the closest to it and who has access to that when the network was really congested. I've kind of lost track of time. When early this year, when a lot of the DEXs were launching for the first time, there was a great deal of network transaction, and this became an issue, and it may become one again. But also network upgrades are keeping congestion low enough that it hasn't been an ongoing issue since then. But that's a bit of a detour. I just want you all to know that that's a thing. It's something we'll be thinking about as a dev community long term. But that's kind of the easy part to describe. Submit API, you need access to that. So then the question becomes, okay, well, how do I build a valid transaction in the first place? And this is where some suite of tooling is going to be necessary, because in order to build a transaction, I must know the transaction hashes and indexes of some currently existing UTXOs. And that's where I must have a synced up connection to the network, right? I have to know the latest UTXOs that are available on the protocol. And so that's where it's going to come in, that I'm going to need some kind of service that, yes, is up to date, and can show me, not the UTXOs as they existed a week ago, 97% of the network or whatever that would be, right? But the ones that exist right now. And I gather that information. Some of it might already be exposed if I'm using a browser wallet, because I can look at the UTXOs owned by that address in that wallet. But for every other address, for example, contract addresses, I'm going to need to query that information from somewhere. And so that's where services like GraphQL come in. And basically, you can build an entire light wallet using only the Submit API and GraphQL. And that would be a really interesting exercise for anybody who really wants to go deep. That's a pretty cool place to start. But you're going to be seeing bits and pieces of that as we start building more and more complicated transactions that pull information from a variety of different places. I'm sure, yeah. What questions does that still leave for you? I'm trying to cover comprehensively, but I'm not sure I got everything there.
Actually, I think you covered it all. I was just wondering, like, so right now we're actually dependent on technically like a free service, right? But it's not scalable for like a production level dApp.
That, it's funny, Dandelion has been used by production level dApps, and that has forced us to rethink some of our initial assumptions we made as an organization, right? We thought we could provide the community service first and then build up the network we really envision around that. And what we found is that when you offer a great community service, people are just going to use it. And so we've been thinking really hard about the process of going from some kind of network that is pay to use, right? Like at least to pay for the servers that we're using. It can't be a net loss to run that community service, but to at least break even. Of course, there's going to have to be some kind of financial compensation for that. The vision is for the Dandelion network to be provided by providers just like stake pool operators, okay? So we'll have a network of people running Dandelion nodes. That network will generate income because people will pay to use it, and that income would be distributed to node operators, following some of the similar logic that's used on the main chain. So that's in production right now. And this is where it gets really interesting to talk about tokenomics. So this course, we're really focused on the dApp development piece, right? Really thinking about this stack from Plutus out to the front end. But obviously it raises these questions about tokenomics, about value creation and value capture that are absolutely at the core of building anything sustainable. So we're going there. And if you're interested in those questions, one of the reasons I'm really excited that Plutus PBL is running right now during kind of these summer months is that when this course wraps, we can turn our attention to a tokenomics PBL where we move beyond just the technical conversation and really into kind of this systems architecture question that tokenomics kind of frames in a brand new way. So definitely going there. A decentralized node, a decentralized API service provider. Okay, so what Dandelion already provides as a community service is packaged with Kubernetes and is made possible for anybody to deploy, right? So people can the other way people can benefit from Dandelion is just deploying what's already built, and you'll still need the computing resources but it's less labor intensive to get it up and running than maybe, building DB Sync from scratch. So it's the combination of now having those services, making them incrementally more easy to deploy, and then eventually creating a decentralized network of those deployments from anybody who's able to provide that.
Yeah, that sounds really good. Great.
Cool.
Thanks for the insight.
Yeah, no, and everybody here is welcome. I just mentioned tokenomics PBL. Then third on the list, of course, is Dandelion PBL, right? So Plutus PBL is where we're really excited to be starting, but this is by no means the only course we want to offer. And we're really hoping that these different courses give people a chance to collaborate on these really important questions. Curtis, what do you think?
Real quick, I just wanted to add that if you are a full production DApp, right, and you're looking for that, and correct me if I'm wrong, that it's not recommended that you use Dandelion for a full production DApp. Maybe use something like Blockfrost until the tokenomics is figured out for Dandelion. Is that the directive that we should be informing the community right now?
It's always been our strongest suggestion. And in our perfect world, the alternative wouldn't be go to Blockfrost. It would be, hey, figure out how to deploy your own Dandelion with Kubernetes. But we haven't provided the instruction for that yet. And so that's why Dandelion PBL is going to be pretty urgent. It would start with just deploying what already exists. But yeah, for production dApps, if you're not going to run all the services on your own, Blockfrost is currently the alternative, right? And if you want to start a good conversation with Cardano devs, this is, people have said publicly, you shouldn't even think about running a dApp if you're not running your own infrastructure. And that's an interesting debate. Yeah, really the best thing to do is before you even think about building a dApp, deploy your own DB Sync. But obviously we recognize that that's a big ask for everybody, and that's why services like Blockfrost exist.
So I've noticed at SnapBrillia that, when it comes to an MVP, and it's a project that has a lot to go, there's a big roadmap, but they're just trying to get out their MVP. It can be costly, right, to support your own DB Sync, especially if you're running everything in the cloud. That cost goes up fairly dramatically than just running, say, a node and using services like Blockfrost or Dandelion, along with some JavaScript libraries. So it's a lot cheaper to just use those services to push out your MVP. But I agree that we have been on our own, like our own personal computers, been playing around with DB Sync, and it's a great tool. It's just very intensive and resource hog. So it's not reason if you're just trying to get something out pretty quickly. So that was our experience, but yeah.
No doubt. Well, and Josh, right, there's other ways. And so understanding those other ways is another place that these are all the pathways that this initial work we're doing together right here can take you down. And just to plug it, there is a Catalyst proposal just to keep Dandelion running as a community service. It's for $90,000 US. And what that would fund is 30 instances of Dandelion that Roberto would spin up, make sure they're operating as a network, and would continue to provide that community service at a working scale, right? Because we already know there are people using this in production. There's no reason to keep it impossible except for the cost of servers. So he's looking at that. And that's, it will be great to use Catalyst funds just to make it possible for people to keep building this sort of utility without worrying about all that background.
I will definitely be voting for that. But so I do have a couple questions based off of what we've already said. For the Dandelion itself, I really do want to get involved in and support and run a Dandelion cluster, Kubernetes. How should I get involved? I know you talked about the tokenomics. Where would it benefit me to get involved? Is that tokenomics PBL the starting point, or where does Roberto need help with that?
It will be, yeah. And he's been, there's a longer story, but look, like this repo is always kept up to date. I just dropped it in the chat. And so for anybody who has the background knowledge about Kubernetes, you could do this, right? And so that's a great place to start. And long story short, he's very much heads down thinking about both the networking and load balancing of that network and the tokenomics to accompany it. And that's where we're going to go. You know, that'll, yes, be a part of the tokenomics course when that happens, right? How do you take this service that's already providing value and design a tokenomics that captures an appropriate amount of that value, right? And all of the questions that come along with that are, I think, at the core of it. That's what we have to learn how to talk about together, right? How do you build services that use these tools, use this thing called tokenomics to sustainably capture value? And sustainably means it keeps it running, but also it means that it's non-extractive, you know, kind of like what we were talking about yesterday.
Awesome. I'm excited. I'll try. I'm trying so hard to get through that tokenomics, but it conflicts with a lot of other meetings.
Oh yeah. Well, no, we'll totally rethink the entire structure of that when the time comes and make sure we're doing it right.
Cool. And then last question. So when you first started the meeting, you talked about the size of the Cardano node. During my learning, I explored many different ways to build Cardano. I built it from source and from GitHub and Docker and VM and WSL, Windows. So I probably have like, I don't know, 10 or 12 versions of Cardano node. Would it benefit others to go through an exercise of cleaning up that storage, that used storage space? Or is there anybody else on the call maybe that's struggling with disk storage and wants to know like practices to clean up? Or James, do you have any tips on cleaning up?
I don't have any prepared. I'm down for that conversation. Yeah, if people are interested. Roberto's got his hand up.
I was just going to say I'm interested in cleaning up and storage issues.
Cool. Okay. I know one of the solutions that I used based off of Krish, because Krish was running out of space, and so he had an external hard drive and wanted to run Node off of that. So I did the same thing just because he was having some troubles, and that worked pretty well for me as well, running on an external hard drive. That was just one thought.
I have an external hard drive. Maybe I could go in that direction.
I think it's a great idea, and I was thinking not only clean up but optimizing, because you know we all have this influx of information everywhere, and we need to find like methods to or learn techniques to store us information, and it would be great to have your input on that. Thank you. Thank you, Chris.
Yeah, great question. I actually don't know how you would optimize it other than like self-contained Docker containers. When excuse yeah, when I think of optimize, that's that's the first thing that comes to mind. Roberto, I didn't find any guides. I just tried it myself. So I moved all the files, my entire Cardano directory, which contains the testnet config files and the DB files and the Cardano node and CLI, basically the whole build. I moved everything to the external hard drive, just straight transfer. I didn't really do anything with it. The only thing I left locally on my local hard drive was the node.socket file. That does not seem to function. At least I couldn't get to function. I spent quite a few days trying to, but I couldn't get that to operate on the external hard drive. It was giving me some permission issues, I assume due to being on some hard drive that it didn't have access to, the service didn't have access to. So once I moved all those files over, I just ran the copy -p command, which preserves the permissions and everything of those Cardano node files. And so copy -p back to local bin because it was a new location. And then I ran the Cardano node. And for me, everything just was smooth. I expected a lot of issues with the DB files being corrupted from the transfer and the testnet config files having issues, but everything just worked as it is. So in my case, I just didn't need any documentation because it was as simple as that. But I am curious if others have a different experience or run into any issues. Krish did. He never really did get his working the way he wanted to on an external hard drive. But I think he was also having some file permissions and directory permission issues. I did see a lot of recommendations in Cardano Stack Exchange to not partition the drive. And that's not a Cardano node limitation. That's more of like a Linux. Linux trying to read through a disk drive that it has multiple logical drives. It has issues navigating the file structure, apparently. So that's all I found so far. It would be kind of a cool experiment to, if others are trying to do it, and see what their results are. Just saw your comment. I'm on Windows WSL. Who else is running out of space? I know I am, but that's, I think, because I have 10 instances of Cardano node running.
That's funny. That's why I stopped using Daedalus in the end, because I had a few different wallets, and each time it had to sync a unique database, and you can only imagine how big that got.
So how big of a machine do we need to run with no issues?
I mean, yeah, who wants to answer that question?
I mean, because the 16 gigas is enough, but then if you go a little further, then you are talking about 32 gigas in terms of RAM. And hard drive, I guess the minimum you can get now is 1 tera, right? So yeah, just thinking of what the market offers, what you guys think.
Yeah, I think a good goal is 32 gigs of RAM and a terabyte hard drive.
Go for the goal.
Right. Yeah. I mean, if you're trying to make it last, but again, that's not accessible. It's not
Yeah,
easily accessible. So it's hard. It's a hard question to answer.
yeah, it has to do with budget. Yeah,
Yeah.
not
And
only
so-
budget, but sometimes you have a machine running and then you have to get another machine. Then you need to space for that. You need to, yeah. So it's
Right.
too many other things.
Is this just to run a node, or is this to also build stuff?
Oh, Juan's question was run without issue. So I aimed a little high.
Yeah, I was going to say it depends on your use case. You know, if you're just going to run testnet, then I mean, even IOHK says 4 gigs of RAM and 16 gigs of storage is fine for that, which I don't necessarily agree with. But yeah, it depends on your use case. If you, like Dom was saying, if you're going to build a full DApp and you're running on mainnet as well, then yes, 32 gigs is recommended. It does depend in my book on your use case and what you intend to do with it. And then once you include all the NICs, the NICs libraries or packages with Cabal and add all that together, it does add up quite a bit. I mean, I'm personally using about 100 gigs of disk storage for my entire WSL build.
Got it. Thanks.
Well, I'm happy to report that while we had this conversation, I was able to downgrade to node 1.35.2 and it synced without issue. So I think I'll keep the whole recording and I'll post this entire recording like I have been on Canvas under the live recordings. Then I'm also going to trim it to right now and include this live lecture as part 3 of the Faucet project that started to roll out yesterday. So the first couple of bits of that rolled out. I just published the video for some initial front-end transactions. That's part 5 of the project, so you'll get there eventually. But right now, this has been a bit of a common ritual every time we've run Plutus PBL, is when we first want to really think about what contracts do, it's helpful to at least once or twice try to interact with those contracts by building transactions on Cardano CLI. Now, we've just been having this conversation, a local node can be hard to run. And so this is the only part of this project where you would need your own local node running in order to follow along and do it step by step. And so the reason I wanted to do this live is for everybody, even if you're not running a node locally, just kind of getting together and seeing this process, it could be enough. You don't have to be hands-on writing every command, but let's sit for the next few minutes and think through this process together. And please, 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 this works best if you just interrupt me as soon as you have questions, okay? So I'm gonna be moving my screen share around a little bit. Let's see, that should look good. So I am now synced up to testnet. I have loaded address and the key as variables in my terminal window. As always, you would never do this bit right here if you were talking about mainnet and any amounts of real value. Just never expose your private keys. But I'm doing it here because this is what it looks like to be working locally, and we are on testnet. I can query this address. This is the address that I built at the very beginning of this course, and it used to have just one nice, clean UTXO in it when I funded it from the testnet faucet, and now it's just as messy as any other Cardano wallet, right? I've used it for a bunch of different things, and we've got plenty going on here. What we're going to use today are these 500,000. These are T Gimbal tokens. Okay, so lowercase t, capital G, IMBAL is the name of the token represented right here. And here's the policy ID. Now, I minted these tokens in Game Changer because there was no reason not to, right? So even if you have the ability to mint tokens on Cardano CLI, you don't have to do that. And I just needed to spin up some quick tokens that I could use for the purposes of this project. They're ready to go. So what is this project? You'll get into it eventually. If you haven't viewed the overview yet, that's okay. What we're going to do is we're going to build a token-gated faucet. And what I mean by token-gated in this case is we have a contract that allows us to withdraw or claim tokens from a faucet if we hold that PBL summer 2022 token that has gone out to everyone who shared their address so far earlier in the course. So there's an initial overview of the validator script itself, also published on Canvas. And we're definitely going to jump into a lot of these Plutus functions one by one, okay? As we go deeper into Plutus, we're going to look specifically at a lot of these functions, read the documentation together. But we're not going to do that yet. I really want you to have this high-level view of what a validator does, what the script produced by compiling from that validator does, and how we can use it, so you can have that kind of full picture. And then once you have that framework, then we can really start to have some fun with more and more specific logic. I just want to point out a few things here, right? These are the things we're checking for in this validator. This validator will return true as long as each of these 5 things are true. Now, the last one is just here as an example. Check datum is okay, always returns true. It actually has no real functionality right here, but I just wanted to show you this tip. You can build placeholders for yourself when you initialize business logic by just following this format right here, and then one by one, looking at each of your guards and implementing the logic for each of them one by one. And the key thing I want you to see here is that we are going to check that an input to this transaction has the access token. The output also has the access token, and it's returned to the sender. And then we're just going to check that the sender is getting the right amount of faucet tokens, whatever they're trying to withdraw, and that the contract gets the rest of those back. As an exercise, you can try to understand the logic of each of those guards down here. And in the weeks to come, we're going to look closely at all this logic, and we're going to try to build upon it. When we talk about this access token, it has a token symbol. And that token symbol is provided by a validator parameter. Now, a basic validator doesn't have parameters. It has a datum, a redeemer, and a context, and it returns a Boolean. But by adding validators, you can get a lot more out of Plutus. And so this is a key concept to understand in this project. What we're able to do because of parameters like this is write the business logic once. All of you are going to be able to use this contract without changing any of the code right here. You're going to be able to create your own unique instance of this contract, and therefore your own unique contract address, simply by changing the token that you want to be distributing, and optionally, the amount that you want to allow people to claim every time they try to hit up your faucet. So where does this happen, right? We can define this. And by the way, this faucet params, this is arbitrary. I wrote this, and you can write your own parameters that consist of whatever set, right? One or more different items you want to be checking for, right? So this is just one particular mix of currency symbols, token names, and this integer here. But you could define your own with whatever name you like, depending on your use case, and you can pass that as parameters. Where we pass these parameters is at compile time. So maybe you recognize this already because you've seen a really basic validator compiler that spits out a working Plutus script. But hopefully you recognize this might look different if you haven't seen it before with parameters. This is the design pattern right here. Okay. We can run our faucet validator script with a certain set of faucet parameters, and these are going to match the ones that we see defined right here. And it's all type checked, right? So this access token symbol is going to have to be a currency symbol. Otherwise, when I try to run Cabal REPL, it's not going to load up. Roberto, yeah.
This is the part that gets hooked up to the front end, right? This script here.
All right, yeah, we're getting there. Okay, so this is going to allow me to have a Plutus script that, yes, will need to be included in the front end. Okay, so after each person compiles their own, and the instructions are right here, right? You're going to make sure to add your token name to your Plutus script, like I did here with T-Gimbal. And then we're going to have a process for you to share your compiled Plutus script, which is just a little bit of data, right? That's another thing I want everybody here to understand. Once you have that Plutus script, it's just a data object that can be shared. It can be passed around. You can use it. You can share it with your team. And that's exactly what we're going to do here. Now, not to get ahead of myself, but that process of sharing that Plutus script, the way we're going to do it in this project, is going to be optionally irrelevant once we have reference scripts on chain. Instead of including the CBOR that's spit out into this Plutus file, you're going to be able to place a script on chain once and then just share references to it. So instead of us passing the outputs around, via Git or whatever other option, you'll be able to put it on chain once, and now we're good to go. So that's one of the biggest upgrades we get out of the Vassal hard fork and into the Babbage era. But we're not using that functionality yet in this project. I want you to really see this way of doing things, and then we can look together at how we transition from here to Plutus V2 and the new Babbage era. Okay, so I already compiled this, and in my file explorer, you can see it here. If I do some word wrap, you can see it's a string. It's a long string, but it's not a wild amount of data, right? It's shareable. There was one other thing. Okay, good. And there's just one more thing I then wanted to call out before now we try to build a transaction with this thing, okay? Everybody here is free to actually change the access token. If you want to make your own faucet, you can replace this part. But for the purposes of this project, you'll leave this part alone because we're all going to build faucets that just use this token that we all got from this course. The parts you'll customize are right here. And that's what it says in these instructions. All of the logic in our contract is going to rely on only these parameters, right? These things defined here. And the script context. What is script context, or what it returns, which is TX info? It's the transaction that you're working with right now. And I'm saying this awkwardly because I still haven't figured out the right way to talk about it. Okay, so I'm going to stumble over my words for a second here, and maybe if somebody else can do this better, please jump in. Okay, this Plutus validator is the rules for validating some transaction. This tells us the list of things that need to be true in order for the validator essentially to sign the transaction, right? If I want to send one of my UTXOs that's in my wallet, I have to sign for that. A contract is not a person who can sign. So what's doing the signing of the transaction at the contract address? It's this right here. When we talk about validation, or what does a validator do? It's basically saying, well, these are the things that are going to have to be true in order for the contract to sign off on unlocking the UTXO that it holds. And so we're not always going to use the word signing when we talk about contracts. What you'll hear about most often is locking and unlocking. We can send funds to a contract address. That's called locking because we lock them there. And then anybody who can meet these requirements can unlock the UTXOs from that contract. It's a pretty big idea. Does that raise questions for anybody?
Is it gonna use just one token to unlock? What would happen if I would have more tokens or half a token?
Beautiful. Okay. So this is functional, but still quite simple. This contract only requires one access token to come in, and then it requires two tokens to go out, an access token and a faucet token, right? So it's just, this is a basic example, but yeah, you can have any number of input tokens required. You would just have to have additional logic that checks for as many tokens as you want. Now, did you say half of a token?
Yeah.
Right, so that part is impossible. Token amounts are always going to be denoted in integers. And the way you get fractional token functionality on Cardano, it doesn't happen here. Okay, so I can tell you the simple example of this, and then at another point, let's talk about how to enable this functionality on the user end. But you've seen that every time we build transactions, With ADA, we're actually talking about Lovelace, right? So if I want to send a half an ADA, I can't write 0.5 ADA. I have to write 500,000 Lovelace. And that's what allows us to think about fractional tokens. But any token you've ever used that has decimal points, it's actually, there's some underlying token that there's one of those. Okay, so we minted, for example, 1.6 billion gimbals, but we wanted each one to be divisible into 1 million parts, just to follow along with the design pattern of ADA. And this opens up different teaching opportunities later on just to match that approach. So when we minted gimbals, we actually minted 1.6 billion times 1 million. And then we registered it so that there would, dApps and wallets would recognize where the decimal point goes and how we're referencing gimbals. So we could talk about how to do that registration, but that would be a bit too much of a detour for right now. But that's definitely something worth circling back to. Any other questions? Yeah.
I was going to say a lot of this stuff with token registry, with doing the seedboard that we're seeing right now with the scripts, that's really going to help that token registry stuff sink in.
Yeah, when you have to, building a front end for a token with decimal places just gives you an extra thing to be thinking about. And I forget to think about it all the time. When I've built some different proofs of concept that use the gimbal token, and sometimes I'll have 6 more zeros or 6 fewer zeros than I meant to have, because it's just one of those details that you got to remember to pay attention to. Always through practice. Okay, final note, and I say this in the intro video, but just really quickly, datum and redeemer must be integers in order for us to interact with this contract. But the logic doesn't care what they are. This underscore just means, yeah, we need an integer, but we're not even going to set a variable for it because we're never going to reference those integers in our code down here. So underscore is your way of saying, I don't care in Haskell, just operate on anything. But do make sure that the datum and redeemer are of these types. Okay. The reason I left redeemer and datum out of this contract is because A, I want you to see what's possible without even using these tools. And B, I hope that you start to recognize some inefficiencies or other design patterns that we could use to build something like a faucet. And maybe you'll have your own ideas about, hey, I don't like the way such and such works. Is there a way we could use redeemer or datum to make that a bit more efficient or more interesting? Okay, so look for those things. And that's exactly what we get to do next together on this project, is say, all right, what would be a different design that we could use to create the same functionality, but with the benefits of datum and redeemer. All right, so this documentation is published, and I got to fix it a little bit, so I'll push the most recent changes again when I post this video to Canvas. But you'll be able to follow along with what I'm going to work through right now by following along with the written documentation as well. All right. What we're going to do is we're going to test this contract. Yeah, I have to get rid, I got rid of integer and unit. We'll save that for a different time. Okay. I've already compiled this thing. I'm about to build an address and prepare a datum. Then I'm going to build a locking transaction. We're going to check to see that it worked and that there is indeed a UTXO at the contract address. And then we're going to try to unlock some funds from that contract. And we have 30 minutes left. I think that's exactly the amount of time that it'll take to get through this. Let's see. So let me switch windows again. I have a sender address and a sender key, but I need the address of this contract. So yeah, so in the output folder, this is where I just compiled that Plutus script to. And I've already run the command to generate the address, but just to review it, I'm going to make this a tiny bit bigger. Let me know if you can't see what's on my screen. I can make it even bigger than that. Just to review this command, I can run Cardano CLI address build. I take the payment script file, which is my Plutus script. I specify the network, because keep in mind, what I just compiled here, you could also compile it for mainnet. Now, in this particular case, that would be nonsense because the assets that we are using at compile time are testnet assets. So I could compile this thing for mainnet. I could get a mainnet address, but it wouldn't do me any good because I don't have those. I don't have the necessary assets on mainnet. But just something to recognize, right? The network is specified after your business logic is compiled. And so you can create addresses for any network if your code is ready to work that way. I output this as an address. There we go. And then I can cat that address, enroll. And I can see that now I've got this new contract address right here. So I'm going to save that as my contract address. And then I'm going to query it, just like I queried my sender address a few moments ago. And there's nothing here yet, right? This contract was just created. It's never been used before. So there's another thing I need to do, and we're going to revisit this, but I'm going to show you something that's going to make a little bit more sense as we move through this lesson, okay? Datum is not used in our contract logic, but datum is still required to interact with a contract. It's kind of another one of those messy ideas to get your head around. So I'm just going to show you this by doing and try to build up understanding as we go, okay? So what I'm doing right here is I'm using another Cardano CLI called transaction hashed script data. And actually, let's look at the documentation for this for just a moment, right? This can take 3 different inputs. It could take a CBOR file, a JSON file, or just some value. And this is the simplest version of this, right? Just to throw a number at it, which is what I just did. I said script data value 1618, okay? But if I was going to use more complicated data in my datum, I could write it as JSON, and I could also hash that. The point is, if I'm going to lock a UTXO at a contract address, it must have a datum hash attached to it. Maybe you've noticed this. Just querying my wallet again. Many of these UTXOs have TX out datum none on them. And if you've wondered why that's there, this didn't exist until smart contracts were released on Cardano, and then it showed up. And the reason is that if we're going to interact with a smart contract, like I said a moment ago, datum must be attached to the UTXOs stored at that contract. So once again, I can get the datum hash of just some arbitrary number. And so 1618, it happens to be this. And we're going to use that. Okay. So what I'm actually going to do here is I'm going to store this as a variable called datum hash. And we're going to use that when we build our locking transaction. I also need the asset ID of that T gimbal token. And there's a few ways I could get that, but one would be just to query my wallet again. And I know that this is the thing that I have 50,000 of. And so this is the string that represents that test gimbal asset. Okay, so I'm going to write asset equals that. And I'm going to use that variable when I build a transaction as well. The next thing I need to do is think about the UTXOs I need when I build my transaction. And the contract says that there must be one of those PBL summer 2022 tokens in the input to this transaction. So here's a UTXO that has one of those. Maybe this policy ID looks familiar to you, maybe not, but that's it. I don't know if anybody else, I've been having the experience of starting to be able to read a little bit of hex, like 5050, I know that's PP, and then 424C is BL. But let's make this our TX, and after we think about this a bit more, there may be two inputs required, but let's think about that for a moment. So this UTXO right here, yeah, it's got the token I need, and then it's got 5 ADA. And so is 5 ADA going to be enough for me in this transaction? Maybe. Let me just grab another UTXO that only has Lovelace in it, just in case we need to cover fees and depending on what we choose to do as outputs. I'm going to call this one TX2. All right, so I got a couple of UTXOs ready to go. I loaded up my wallet as sender and sender key earlier. I stored the contract address as contract address, or ADDR. There it is. I have the datum hash. I don't need to echo that because I can see that I did that up here. And I also did the asset, right? There it is. Okay. And that's everything I'm going to need in order to build this locking transaction. Let me zip back over here so we can look at this before I copy it over to my terminal. All right, so I'm going to build a transaction on the Babbage era. It's going to have 2 TXNs, like I just specified. And what we're going to do is we're going, oh, wait, hold on, back up. I did this wrong. And there's actually only one thing I have to fix. But I'm not trying to unlock right now. Okay, so hopefully, and Sam, let's come back to that question too. Okay, maybe the fact that I made a mistake can kind of help Sam with the question you're saying here, okay? I picked the wrong UTXO. I picked this UTXO because I was just moving along and I thought I needed the PBL summer 2022 token. And that's why I picked this UTXO as TXN number 1. But I don't need that token to lock funds at this contract address. I need it to unlock funds. So actually, I'm not going to use this UTXO until the next step where we're actually unlocking something here. And so I need to pick a different UTXO, not the one that has that access token in it, but the one right here that has the T gimbal tokens I'm trying to lock. I hope that mistake makes sense. And you know, if you're seeing for this for the first time, I apologize for going down the wrong pathway. But hopefully this is helping you think about, okay, locking. What am I trying to lock? T gimbals, because that's what I want people to be able to claim from my faucet. Later, when I try to unlock, I'm going to need this PPBL Summer 2022 token. Now, Sam, back to this question, right? Yeah, I'm explaining which one to pick, and I'm using human logic to choose the UTXO. I'm doing this by hand, right? Every wallet that all of us have ever used to build transactions automatically is doing this under the hood. And that's called coin selection. So if you've ever heard the term coin selection, this is a very interesting theoretical branch of building, not only on Cardano, but also on Bitcoin, for example, which follows the UTXO model. Which UTXOs should we consume in a transaction? With Cardano, the question gets even more interesting because we're talking about extended UTXOs that have native assets within them. And so coin selection becomes even more complicated. And there's people working right now, often as a hobby, just to kind of try to optimize it. So that's another thing that we could look into a little deeper later. I know the Mesh team has been working on that, and Game Changer Wallet provides a few different examples of coin selection algorithms. Roberto.
When you say you made a mistake with the UTXO you picked, it's not because it's the wrong type or anything, right? It's just because for this example, that's the wrong UTXO because it has that PBL, but that token wouldn't really make it. You could still use it to provide funds, right? It doesn't really matter.
Yeah, yes, exactly. I could still use this UTXO if I needed these 5 ADA to make the transaction work. And I could still, you know, I would then have to take this as input, and I would have to just make sure to balance the transaction by sending it somewhere, i.e. back to myself, right? But yeah, the mistake I made was, this is a locking transaction. What am I trying to lock? I'm trying to lock tokens in my faucet. These ones. This is the token that I identified when I compiled the contract. Okay, so yeah, I'm not trying to lock my PPBL Summer 2022 token. I'm trying to lock these test gimbals. So let's use that one instead. Now that one actually makes it easier to decide if I need an extra UTXO because this one only has 1.3 ADA in it. I'm definitely going to need this additional UTXO just to cover the extra ADA that I want to place at this contract. So that's good. All right, so I've changed that. Now I've got 2 UTXO inputs that I'm going to be pretty happy with. And now let's talk about the outputs. Yes,
so actually, anybody can send anything to this contract. You can't restrict who is that someone sends anything to this contract, or?
Excellent. Yes, that is exactly right. And this is where Cardano development takes an interesting twist. Okay. Nobody can stop anybody from just sending funds to this contract address. But how do you unlock funds from that contract address? You have to be able to meet the rules that are specified in the validator.
Yeah.
Right? So yeah, anybody can drop money into my piggy bank, but getting it out, that's much harder to do.
So everything else is lost that not fits to these validations.
Now here's where it also gets interesting. Okay, I want to say 2 parts to an answer to that question. if somebody placed a UTXO at this contract address and it had datum attached to it, and I knew what that datum was, I could still unlock it. All I would have to do is use it as an additional input from the contract address, right? So I could actually build a successful transaction by meeting all of these rules and then just adding to that an additional UTXO with some other funds. And because all of this logic is based on the context of the entire transaction, as long as it sees that each of these things are true. I mean, does at least one of the inputs have this token? Okay. Do at least the outputs cover this piece and this piece right here? And does the faucet token get sent back to the contract? Okay. As long as those things are happening, you can unlock this UTXO. And actually, I'm saying all that. I'm not right. I need to think more about. Well, hold on. That's actually an interesting extension question for us to look at. I'm not sure if what I just said is true now that I'm thinking about it. But let's circle back to that. Let's see this first, and let's maybe try to do an experiment with locking some faulty funds and seeing if we can get them. The case where those funds will be lost forever. And right, there's a lot of this on testnet because people have been playing with this and trying to work around it. If you don't include a datum hash on an output to a contract, you can't unlock that UTXO. Okay, so if you forget the datum hash bit, now you've locked funds irretrievably. And that's on the protocol design of Cardano. So we're going to make sure to include a datum hash. So this is what we say right here. And I want you to think about this bit right here as kind of one block. Okay, this is one thing right here. And it's all going to produce a single UTXO that will have 5 ADA, some asset, and a data hash. This output is not going to a contract address. It's just going back to the sender, so it doesn't have a datum hash. This is something you've already seen. And then we can send the change back to the sender as well. Now we are going to need this additional TX out because I don't want to lock all of my 500,000 test gimbals right now. I think, yeah, let's lock 12,000 of them. And then let me return the rest of those. So 500,000 minus 12,000. I'm going to return the rest of those to my wallet. I don't need 5 ADA locked at the contract. I don't even need 2, but just to keep it simple, I'm going to put 2 ADA there. I'm also going to keep a minimum amount of ADA in this output back to myself with the rest of the test gimbals. And that way, the additional ADA will just be sent back to me as a UTXO that has only Lovelace in it. So this should successfully lock these funds. I've set TX in 1 and 2, the contract address, the asset, the datum hash, the sender. Again, the asset, again, the sender. All of that looks good. So let's take that and let's run it. I just CD'd into my transaction folder because I already have the protocol params here. So let's run that. Assets are unbalanced. Oh yeah, that's because I did the arithmetic wrong. Nobody stopped me there? 480,000. It needs to be 488,000. That's good. So I'm off by 8. My arithmetic was off by 8,000 of these T gimbal tokens. So let me fix that. 488,000. Let's see if that works better. Clear. Try this. All right. Now, maybe I've said this before, but worth repeating. I have not submitted anything to the network yet. All I've done is I've successfully built a transaction. And so you can play with this, okay? You can play with Cardano CLI just by seeing whether or not you can successfully build a transaction. And it's fun to like try a bunch of different things, see if you can break it. And we're going to do that in just a minute after I sign and submit this transaction. But let's lock these funds first and then have some fun with unlocking. Okay, so that's been submitted into my mempool, out of my mempool. And after the next block, I should be able to query this contract address again. Early days, yeah, we're still doing our own math. Luckily, again, right? Think about all of just the arithmetic that wallets are doing for us to make sure that every transaction is balanced. Now, when we do move to the front end and we start building this exact same transaction in the front end, that's what's going to do the arithmetic for us, right? So we're still going to have to hard code that arithmetic once so that we can then use it in an automated way every time somebody interacts with our front end. All right, I should be able to query the UTXOs on testnet at the contract address. And now, sure enough, there is one UTXO there for the first time. It has those 2 ADA, it has the 12,000 test gimbals, and here you can see the TX out datum hash has the datum that I included on the transaction. Good, funds are locked. And we could look for this address on Cardano scan, but in the interest of time, I want to try to unlock this thing. Unlocking is really where the work happens, okay? So let's take a high level view of this unlocking transaction first and think about what we're seeing here. I'm going to break it into a few different blocks. Okay. So boilerplate up here, where are we taking inputs from in our new transaction, in our unlocking transaction? Well, there's still going to be a user interacting, and as specified in the contract, in the validator, we're going to require that auth token. And that's the one. This is the UTXO that I expect to have the PPBL summer 2022 token in. I may need an additional UTXO to make sure I'm covering fees. So this one, I would want one with simply Lovelace in it. And then I'm going to need the UTXO from the contract address. And unlocking from a contract address is always going to require additional fields, like we see here. Oh, do I want to use one of the UTXOs in my wallet? Yep, anytime. All I'm going to have to do is sign for those. But if I want to unlock from a contract, I have to provide the Plutus script, provide the appropriate datum, and provide the appropriate redeemer. The redeemer can be anything, as long as it's an integer. The datum must be this integer, because that's the one I hashed to get this datum hash up here. And then the Plutus script has to be the file that I just compiled. This bit right here, this is the Plutus V1 way of doing things. And with the upgrade, we have a new approach to this. I just want you to see this one first. Finally, when you're trying to unlock funds from a contract, you also have to provide collateral. This is to ensure that you're using the network honestly. And interaction with collateral is changing with the hard fork as well. All right, this can be a bigger topic, but I'm going to save it for later. What are our outputs? Well, I want one output that goes back to the contract address. I want another that claims whatever I'm trying to claim from the faucet. And then one more that sends my auth token back to me. I could combine these two, but I'm choosing not to. I want to keep that auth token separate from other assets so it's easy to use later. But that's a design decision. And when you build a front-end dApp, you can decide how inputs are redistributed to users. I think this is much more user-friendly because it ensures that they'll be able to use their auth token again without having to do the extra lifting of extracting that auth token from some other UTXO that has other assets in it. But that's a choice. Can anybody see what's missing right here? This UTXO, it's going back to the contract address. And remember, every time you want to lock funds at a contract address, you got to include the datum hash. And so it's easy to forget this, okay? It's easy to overlook, oh yeah, I'm unlocking this time. I don't have to worry about the steps of locking a UTXO. And so I've done this a few times myself and just wanted to make sure to highlight it today, okay? Even when you're unlocking funds from a contract, if any part of what you're doing requires you to send funds back to that contract, you got to make sure to include that datum hash again. So let's think about some amounts now. I just stored 12,000 test gimbals at this contract address. In my compiler, I specified the withdrawal amount is 3,000 at a time. And my contract logic expects me to send at least that many faucet tokens to the sender and to return at least that many, take away the withdrawal, or the amount that were there, take away the withdrawal back to the contract. So what we have here is logic that's only going to work if I'm sending 3,000 of my asset to the sender and 9,000 back to the contract address. 2 ADA is plenty. It's the exact amount of ADA that's already there at the contract address. We're not going to let that change. 2 ADA is enough to accompany these new assets that will be entering my wallet. I guess it's still, it's the wallet they originally came from, but that won't always be the case with a faucet. And then my auth token comes back. And then this piece right here, required signer hash. I have to add this piece right here because of this TX info signatories, because I'm using this in my Plutus logic. All right, I recognize we are just about out of time. It's probably going to take another 10 minutes to finish this up. So I'm going to keep going just for the purposes of this recording to make sure it's complete. Obviously, if you have to jump off, thanks for being here. But if you can stick around, we can complete this loop in the next few minutes. All right, so I just want to look through this list now and cover these variables and make sure that all these variables are set. And then I'm going to try to run this transaction. So back on the command line, I can query the contract address. Let me also query my sender address once again to gather the UTXOs I need. I know I need a contract TXN, contract TXN. And so there's only one choice for that, this one right here. I'm going to grab that. Good. Now I need an auth token TXN. That's this one that I was looking at before. All right, now we're finally ready to use that one. Auth token TXN is going to be that one. And then we got 5 and 2 is 7. Yeah, we might need a little bit extra for fees. An extra 6 or 7, that's fine. So we'll make that one our fee TXN. Okay. And then collateral can just be any UTXO that has a bunch of ADA in it. Usually 5 is plenty. It does, but it can be more. And I'm not worried about losing this. So I have a UTXO down here that just has 20 ADA in it. And I've been using this one for collateral. Collateral, what do I call it? Yeah, just collateral. That's at index 4. All right, now I need the path to my Plutus script file. Let me go into output for a second. Oops. And I've got this path to that file. So my Plutus script file is going to be, this was called PBL faucet test gimbal.plutus. Okay, so a direct reference to the Plutus script itself. And maybe you can see right here, right, when I don't have to attach this entire file every time I run a transaction, the size of the transaction is going to be smaller, and that's going to save me fees. And that's part of what we're getting out of the upcoming upgrade. But we're doing this pre-upgrade style once again right now. We're going to attach that entire Plutus script to the transaction. All right, the datum hash was already set, and the datum value, I just hard-coded there, so that's fine. My asset is already set. These are my test gimbals. But I need to set the policy ID of my auth token. And that's this one right here. Okay, auth token, sender. The last thing I need is the pub key hash of my sender wallet. I'm going to do this in a different tab, just so it's easier to navigate. That's the wallet. And so what I can do here, this is the wallet that I'm using. And what I want to do is put on CLI. I think this is an address command. Yeah, key hash. I need the pub key hash. And that takes as input a payment verification key file which is what I have. It's that payment VQ. So payment verification key file for payment.vkey. And so here's the hash that I need to identify that required signer. Once again, the reason I need this hash is because I'm using it in my contract logic. And the way I'm using it in the contract logic is just to identify where the output is supposed to be sent. We'll talk more about that. And when we build this same transaction in the front end, we're not going to have to worry about it because the mesh guys, they just automated it. This is another thing that they just took care of doing for us. So we get to look at this right now, even though the dev tools that we will soon be using as we build on the front end have already improved beyond this necessity. That's pretty cool. But I think those are all of the variables we're going to need. So let me cd back to that transactions folder. And let's just try to build this transaction. I'm just getting rid of the spaces off screen right now. And I'm going to grab this whole thing we were just looking at in my code editor and place it here. All right. And there's our boilerplate transaction build, Babbage error, identify the network. We identified the auth token TXIN and some fee TXIN. We identified the contract TXIN and along with it, the accompanying script file, the necessary datum and the necessary redeemer. We provide collateral because that's required. And then we have a few TX outs. We're careful to make sure that the TX out back to the contract still has datum attached to it. And then to meet the restraints of our validator or the constraints of our validator, we got to make sure to send 3,000 test gimbals and that auth token back to the sender. And then because we're checking where we're sending those, that logic requires us just to identify who that sender is right here. All right, I don't know if this is going to work. I'm curious. Let's see. All right, so it did. Look at that much higher transaction fee. Instead of a little bit less than 0.2 ADA, we've got, you know, almost 2/3 of an ADA right here. It's expensive. Let's sign. Well, actually, you know what? Let's just break this just a few times before I submit this. The most fun part about doing this, I know we're short on time, but is to try to see if we can get some of the errors that we saw in our Plutus script. So watch this. Our Plutus script expects us to send an amount of withdrawal tokens equal to or greater than, right, what's specified as the withdrawal amount, which is 3,000. So technically it says I'm allowed to take more than that, right? But if I did, in order to balance that transaction, I would not be able to return the rest to the contract address. So watch this. What if I tried to claim 4,000 of these and I only sent 8,000 back to the contract? I'm taking a risk here. I really hope this doesn't work. Let's see. Okay, so we get command failed, transaction build error, all right? But this is the best part right here. Script debugging logs. It says must return remaining tokens to contract. And this string right here is exactly what I wrote right here. Okay, so these error messages, these trace if false messages that you add in your validator will show up when you test your contract using the CLI. This is not yet true for the front-end template. It's a bit of a hard problem to deserialize these errors in a way that makes it really dev-friendly to read these errors from the front-end dev environment. That's something that we're working on. And again, that's another thing on the mesh roadmap, is to be thinking about that. But it's a bit challenging. In fact, in the earliest days of building Plutus contract, these errors wouldn't even show up on Cardano CLI. And it was a major relief when that was added to one of the CLI releases, okay? But you can see I was able to get this error, must return remaining tokens to contract. Let me just quickly, let me do this one more time. Well, okay, what if I met that constraint? I can still try to take 4,000, but I'll send 9,000 back to the contract. I hope you can imagine the error that we're going to get right now. Assets are unbalanced, right? I tried to consume 1,000 too many of these, okay? So this transaction, it doesn't even get me to the point of the Plutus error because I'm not even building a balanced transaction in the first place. So I hope you can start to see these layers of error that you will get along the way, right? First, you got to build a valid balanced transaction in the first place. Then you got to validate it. All right, so let's try this one more time. Maybe I can leave 10,000 tokens at the contract, but only send 2 to the sender. And in that case, notice that I get a different error. Faucet token must be distributed to sender. I wrote this error, so maybe it's not descriptive enough, right? That's not exactly telling me what's going on. Maybe I could say you must distribute at least the right amount or whatever. But that's a finer point, and I kind of built this pretty quickly. But yeah, there were 2 other errors there, but we're already now 11 minutes over. So what I'm going to do is just finish this thing up. I'm going to make those numbers correct. And I really recommend this part. If you've done the work to get a local testnet node running, what you have earned yourself is the ability to test contracts in this context. And just speaking from experience, I've learned a lot by tinkering this way. If we had a little bit more time, I would try to replicate the other 2 errors, the auth token missing from input and output, but maybe you can imagine how we would recreate those errors by using the wrong TX in or not including it in the TX out, okay? So just really, really powerful opportunity to kind of build up your intuition about how these contracts work, is to just try to make faulty transactions and check that all of your logic is working. By the way, the PAB and the Plutus Playground, they automate all of this, right? So if you've studied Plutus Pioneers or been learning Plutus any other way, you know that a big part of what the off-chain part of Plutus provides is the ability to automate all of this testing. And obviously, that's a really, really good thing to have. I'm doing it by hand right here because I found that when I learned the first way of testing, it felt too abstract to me. I just didn't feel close enough to it to feel like I was understanding it sufficiently. And so I wanted to provide this as another way to think through contract testing. But this is really a learning approach more than a production approach. And if you're building a dApp at scale, obviously you should be using everything that Plutus provides to just test all the possibilities of what your contract might do. We'll get to that. For now, let's just make sure this transaction still works. It does. The fee is the same because that's deterministic. And now I should be able to sign and submit it. I can watch my node. It's been added to the mempool, right? There's our submit API right here, right? It's running locally, but when we talk about submit API, this is the step it's doing, right? I have a piece of data, right? I have a piece of data called unlock signed, right? That's just a file, right? And what am I doing with that file now that it's ready? I'm submitting it to the network. We'll give this just a moment so we can look at the results. while we're waiting for this, thanks for staying late. What questions do you have now?
Hey James, there is another when you're doing the datum, and I think it's embedded value.
Yeah.
So I know, I think it like removed the hash step. I'm not 100% sure, and I was wondering if you could offer a little bit of clarification, or that might be out of scope, and that's fine as well.
100%. So we're in thinking about kind of the learning trajectory in this course. I want you to have kind of the lowest level understanding first, and then we'll build up, like, because that's a great example of another tool that makes it a bit easier to work with data. Okay. So yeah, today's lesson is just a stepping stone to get us closer to that, understanding these different ways to interact with data.
I love that. Thank you.
You bet. Nelson.
Yeah, we talk a little bit about anyone being able to make a transaction to the contract address, right? So is there a way, as maybe a validator or something, that we can revert anything that doesn't make sense to the contract at all?
Oh man, okay. No. They're okay. So you're saying, like, if you accidentally submit funds to a contract address and you're like, oh wait, I shouldn't have done that. Yeah,
something like that.
There really isn't, right? The Cardano protocol does not have a Control-Z command on it, and then that's kind of the beauty of this immutable ledger. But it's also the reason we have to be really careful working with it.
Yeah, what I meant was, if someone did that to my contract, say, can I write something in my contract that reverse those transactions to them if it's not what I want?
It's interesting, right? Because yeah, none of us want our contracts to be filling up with noise. So that's a useful thing to have. And it depends on a couple things. You need to, first of all, if they deposit something at your contract without datum attached to it, you're out of luck. But luckily, in the front end, whenever we interact with a contract address, it's easy to filter out the UTXOs that don't have datum attached to them. So even if they're on chain, they might not get in the way of kind of like visually looking at what's at that contract. But still, that's not a completely satisfying answer, right? So that part, that's just messy. For UTXOs that do have datum attached, they ought to be unlockable, and you would have to be able to match that datum. If you could match that datum and you could build a transaction that meets the requirements of your contract, that yeah, you could build that. And here, let me show you one more thing on that. But first, I can see this transaction went through. So just taking a moment here to query this contract address again. Here we go. Okay, so what's in this contract address now? Of course, 9,000 test gimbals, because 3,000 got taken out with a different UTXO. Okay. And I've got these 488,000 test gimbals here from my original allotment, but I should also have, here's the other 3,000 that I just withdrew from my own faucet. And I have my PBL summer 2022 token back, but it's in a different UTXO. There's a lot of interesting stuff that we're going to be thinking about with some of these details. But for now, that's probably as much as we're going to cover. But Nelson, to your question about creating a way to unlock those extra funds, all right? This, and I was trying to think about how simple we can make this faucet contract. And so I left a lot out of it. And to me, the the last thing I cut out of it, and it was a tough call whether to use it or not. But yeah, there's no backdoor in this contract right here. There's no way for somebody to just come and clean up any of those extra UTXOs that maybe somebody accidentally sent to me, or maybe I just want to empty out this faucet and not have anything there, right? There's no way for me to do that the way this contract is written. And that's the first thing personally I would add to this contract if I was going to build upon it, right? So let me just show you a little example of what that looks like. Here. No, it's not this one. This one. Treasury. So, no, that's not it. This one. Okay. Yeah. So an escrow contract has a couple of things in common with a faucet, right? I mean, people have to be able to unlock things at a certain time. But the thing I really want you to see is this is a case where we're using Redeemer to provide a backdoor. Okay. So here, this is the Redeemer bounty action. We call it action. And then our logic doesn't just have one set of rules like you see in this original contract. It has 3 different cases. And when somebody builds a transaction to interact with this contract right here, instead of just putting an arbitrary integer as their redeemer, which is what we were able to do here. This served no logical purpose. I could write any integer I want right here, right? Instead of using that for no purpose, in this contract, what you use for the redeemer specifies the action you want to take. Are you here to cancel this UTXO, to update it, or to distribute it? And depending on which of those statements of intent the user might make as they build their transaction, the logic is going to be different. Deadline reached and signed by issuer, those are the only things we check if somebody says they want to cancel this thing. If they want to update, we can ignore deadline reached. We're still going to use signed by issuer, and then we're going to look at a couple of other things. Okay. And so what you're able to do is to create that kind of safety switch that you're talking about. You could do something like add a case right here, add an action, and you could use the redeemer to do this, where signed by some pub key hash, right? Signed by the issuer of the faucet was the only thing you had to do. And in simple terms, what this means is that you can build in the ability for the owner of a faucet just to empty the faucet at any time, right? Which would be a helpful thing to have. And I repeat, that doesn't exist here, but I think it would be, that's probably the first thing, again, I would add to this.
Yeah, I got a rough idea. Thanks a lot.
Yeah, man. And Dagwell, a way to force a standard datum onto all incoming transactions, right? This is great as well. That is a front end or PAB question, okay? Because think about this. The contract logic here is irrelevant until I'm trying to unlock a UTXO from a contract. This can't do anything to stop me from sending funds into a contract, right? So that check, that force of including datum on all transactions, it must be handled by the orchestrator, by the PAB or the front end, whatever you happen to be using. And so, yeah, I would, you know, in our front end, let's build a guard for that. If you don't include datum on a contract, it won't work. And actually, I'm saying this, the mesh guys already built this. As we'll see, they've been using TypeScript to make sure that we are using contracts correctly. No, they didn't do that yet. They did it for output. You see, I'm getting ahead of myself. Anyway, yeah, I think we should build a guard into our front end, though, you know, just to make sure that the datum is there before allowing a transaction to go through. Okay, well, we went over time. I really appreciate people sticking around for this. I hope that was helpful and maybe even a little fun. Like I said, I really recommend this approach for people who are trying to build up their mental models or their intuition about how Cardano and Plutus transactions work. And that's all for today. I can stick around if anybody has any additional questions. Otherwise, we can pick this up same time tomorrow, where my first priority is to hear what you've been thinking about after seeing this today or reviewing any of the other modules. And then if there's time, we can start looking at these very same transactions in the front-end template. Good stuff, y'all. You're welcome. Thanks for being here. Thanks, Roberto, Nicholas, Nelson, Yuli, Trevin, Sebastian.
Thank you. Bye-bye.
Cheers, everybody.